Rail straightening press. The rail straightening equipment shown in this presentation is designed for the straightening of a wide range of standard rails such as transport rails, train and tram rails, grooved rails, block rails, switch and crossing asymmetric rails, tongue rails, guard rails, full web rails, crane and conductor rails, etc. The four-sided straightening press is designed around a strong and rigid machine frame. The 8 support blocks are adjusted and positioned by means of servo drives. The distance between the supports can be set from 650 mm to 3200 mm. The side supports can swivel by means of small hydraulic cylinders. The sufficient straightening force is provided by 2 vertical hydraulic cylinders with a press force of 4,400 kN each and 2 horizontal hydraulic cylinders with a press force of 2,600 kN each. The 2 support blocks at the top of the press can be adjusted to 3 different heights for low, medium-high and high rails. All straightening cylinders are equipped with a stroke measuring system, which ensures the exact position and control of the press tool during the straightening. The speed of the straightening cylinders is up to 150 mm per second for the approaching stroke and 1 to 50 mm per second for the working stroke. The cylinder movement is controlled by a joystick from the operator desk. Their movement is secure and there can be no collision. Only one straightening cylinder can operate at the same time. The straightness is measured with a laser measuring system installed inside the press and above the rail. The measuring system consists of a linear guide with a measuring head equipped with laser sensors and 2 cameras which monitor the position of the measuring head and carry out the measurement. During the measurement process, the rail is positioned inside the measuring range and the sensor moves along the rail. Within a few seconds, the straightness results are displayed on the screen. The results can be stored in a database and archived. During the straightening process, the rail is always supported by 2 mobile support blocks. On the basis of the results of the measuring system, the blocks automatically move into an appropriate position. The rail also moves into the optimal position. This is typically the position where the bulge is the biggest and where the straightening cylinder should press against it. The twist device and the abutment block are designed for the alignment of torsional deformation. In the case of torsional deformation, the rail is fixed in the abutment block and twisted by means of the twist device in the opposite direction of deformation. The distance between both devices is about 3 meters. The maximum torque is about 275 kN at 320 bars. The rotation speed is up to 12 degrees per second. The twist angle ranges between -85 and 85 degrees. Automatic tool change is carried out by means of a robot and a pneumatic gripper. The robot is installed at the top of the press. The tool magazine is beside the press. In the tool magazine there is a set of tools ready for the next type of rail or for automatic change. The tool changing procedure takes about 7 minutes. The main hydraulic power unit and hydraulic valves supply the press with oil and 320 bar working pressure. The whole straightening equipment is set up on a movable platform. By means of this platform, the press and the operating desk can be moved from one railway to another. This function allows more flexibility and higher output productivity. For this purpose, a special hydraulic coupling system has been developed which enables quick and automatic coupling and decoupling of large hydraulic hoses without oil leaks. Before the measurement, the rail is positioned in the longitudinal direction and centered in the transverse direction. The rail is transported through the press by a combination of driven, spring-loaded and undriven rolls. If the straightening is carried out from above, the rollers lower automatically. The measuring system itself is equipped with a position control system. The position control system is used to compensate for the self-motion of the linear guide and the measuring head and to ensure that it does not influence the measurement results. After the measurement, the results of the vertical and horizontal straightness measurements are displayed graphically. The accuracy of the measuring system is ±0.02 mm. After a successful rail straightness measurement, the data are calculated and classified according to the predefined standards and forwarded to the master control system. The rail cannot leave the machine before the results are within the requested tolerance range. The presented equipment enables a complete rail straightness control and is a very flexible and optimal solution for rail manufacturers. Thank you for your attention.